Friends, welcome to my workplace at Ranaghat, West Bengal, India. Let us observe management of this very hard nucleus. The exposed part of the phaco needle has been increased to deliver more ultrasonic energy into the substance of the nucleus. Some superficial cortical lens matter is removed. Having done that, the handpiece is rotated, bevel is up, and now watch submarine job. The nucleus is pushed little down, the tip is buried into the substance of the nucleus, and it goes through the substance of the nucleus as a submarine moves through water. And as it crosses the central part, reaches midway between the center and the opposite equator, the chopper is used to divide the nucleus into two heminuclei. And this is a very good crack. The nucleus is rotated on 180 degree, and along that crack the nucleus is completely divided into two heminuclei. This is a real-time video of the nucleus management. This is another job on a heminucleus, and this is another job on the same heminucleus. By two jobs, this big heminucleus has been divided into three smaller pieces. And now the lens matter, the nucleus, is rotated, and then the other heminucleus also is being chopped. This is the first chop on this heminucleus, and by one chop this heminucleus has been divided into two pieces. And now these pieces are being emulsified. Ultrasonic energy used in this case is 80%. Flow rate is 45 ml per minute. Vacuum is 450 millimeter of mercury. This is Oatley Cataract 3 phaco machine. If necessary, a large nuclear piece is subdivided into smaller pieces and then emulsified. I usually start emulsifying these large triangular nuclear pieces from its apex, and very gently, very carefully the pieces are emulsified. At this time I came out to inject some visco, and this is 2% hydroxypropyl methyl cellulose. Now I am trying to rotate this heminucleus, but I am finding it a little cumbersome to rotate this. There is some attachment between these fragments. They are not completely free. So it took a lot of time to mobilize the pieces. Visco again, and now I'm going to decrease the exposed part of the phaco needle and then emulsify these 3 nuclear fragments, because if the exposed part of the phaco needle is less, the chance of postcapsular rent is also less. Now this air bubble is causing some visibility issues, so I come out, inject visco and replace this air bubble with HPMC. Then I introduce the tip of the phaco needle again. Here it is. Now I go with irrigation on so that no air bubble goes into the anterior chamber. So if you don't want any air bubble in the anterior chamber, please go into the anterior chamber with irrigation on. And now I start emulsifying these last 3 nuclear fragments. This is the 3rd nuclear fragment, and see the white coating of this brown nucleus. The epinucleus has degenerated so much that it has become a card-like substance. And this is the last nuclear fragment. At this time we must judge how the posterior capsule is behaving. Is it far away from the phaco needle towards the vitreous cavity, or is it trampolining? Is it flapping and tending to come to the phaco tip? If it is so, then the sure way to prevent posterior capsular rent at this moment is stop emulsifying this fragment and put the IOL first. But in this case, I decrease the vacuum and flow rate and am emulsifying this last nuclear fragment. At this time the flow rate is 25 and vacuum is 100 millimeter of mercury. And I am very slowly emulsifying this last nuclear fragment, and the posterior capsule is far behind. So this is how this hard nucleus was managed. Rest of the surgery is not going to be shown in this case. This video is just to show the nucleus management part. Thank you very much for your attention. Hope this video will help you in developing your surgical skills. Be a great surgeon and serve your patients with love, respect, empathy, and great surgical competence.